So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over lists and outcomes which is connected to the topic of probability. Now we can arrange all possible arrangements and combinations when events are combined in an ordered list or sample space diagram. Now by doing this it makes it easier for us to see which events are more likely or less likely, and also find the probability of particular events occurring. Now, as an example, to participate in the Euro Millions, you need to select 5 numbers from 1 to 50 and then 2 numbers from 1 to 12. Now, I know often the Euro Millions gets advertised whether you're going to a shop or on TV, where it says like the jackpot, estimated jackpot is 88 million or 56 million, or even goes into hundreds of millions, so like 130 I think is a record. But if you ever thought, let's say, how many different combinations are there of selecting those numbers, so 5 numbers from 150, 2 numbers from 1 to 12, that would guarantee to win you to match the winning numbers of the Euro Millions. Now that number can be calculated by looking at all the different combinations, and we actually get an answer of 139,838,160, which is actually 139,838,160. So that's how many different combinations there are of potentially winning or guaranteeing winning lottery numbers. So if you wanted to guarantee winning the national lottery, and you'd need to buy 139,838,160 tickets to guarantee it. However, what you've got to think about is you will be spending that much, and each ticket costs about £2.50. So if I multiplied that by 2.5, I would actually need to spend the cost of buying all those tickets and that this is at £2.50 per ticket. Then it would actually cost you, and if I just write the digits because I've got it on my calculator, so it would actually cost you £349,595,400 to buy those tickets. So you're spending that to guarantee buying the National Lottery, which, even if you did have that amount of money, you probably would not be watching this video. You're probably having a private tutor to at least help you with your maths. But also you've got to think to yourself, what if someone buys a £2.50 ticket and just from their pure luck gets that, then your money that you've invested will be halved, and then if there's 3 people it will be split into 3, so it may not actually be worth it to spend that amount of money just to get the jackpot amount. Now when writing an ordered list of outcomes, there is a certain way that will make your life a little bit easier. Now, yes, you could do it randomly, but you'll be scratching your head, particularly to find the last ones that you are missing. So if you find like a system, or what we call to write your list systematically, then what it means is that you'll do it not only quickly, you'll also do it relatively accurately as well. So if we take this very simple example where a coin and a fair die are thrown and rolled respectively, what we want to do is list all the possible outcomes. So obviously on a coin, if I just write that down, so on the coin, my 2 options are either a head and a tail. Now, just to abbreviate, I'm just going to call that H, and I'm going to call this T. Now, on the die, I can get 1, 2, 3, 4, 5, and 6. And what I want to do is I want to list all the possible outcomes. So, list of all outcomes. So what I'm going to do is I'm going to keep one of the events consistent, the same, and change the second one because I've got 2 events happening. And then once I've exhausted all the possible second events, I'm then going to move on to the other event in the first option. So what I mean by this is if I look at my coins, if I just write C and D, obviously C means coin and D means die. So here I'm going to start by just having a head, and I'm just going to change the scores of the die. So I've got 1, 2, 3, 4, 5, 6, and again what I've got on the coin is a fixed head. So then what I'm then going to do is change that up because I've done all the possible head combinations. So now on the coin and the die, I should learn to practice writing in the straight line. I'm now going to have a tail in which I've got 1, 2, 3, 4, 5, 6. And I've got T, 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 T. So looking at this, and if I count how many different combinations I've got, you can see that I've actually got 12 different combinations. So I've got a total of 12 combinations that I could get, like so. So let's have a look at some exam style questions then and see how this relates to what you can expect when you're doing a test or an exam. So in question 1 it says, or example 1, it says that 4 teams A, B, C, D play matches against each other. Each team plays each other once. Complete a list of matches. One match has been done for us. So for this, what we've got is, I'm just going to change this because I'm going to try and save time in terms of playing. So what I've got is I've got A, V, B. Now I'm going to stick with A and we're going to write down all the matches of A playing each other. Now for this there is no mention at all about home and away, so they're only playing, also it also says that they play each other once. So those sports fans who know about home and away games, we're only looking at one match. It doesn't really matter. Let's say they're playing in a tournament, so they're only going to play each other once. So what I'm going to do here is I'm going to keep A as by itself and as consistent, and we're just going to change the team that they play. So A then plays B, then A then plays C, and A then plays D. So that's all the games involving A. So then what I'm going to do is I'm going to involve B. Now B has already played A, so the only two teams they can play is going to be C, and B can play D. And then finally for this we've got C, and the only team that C hasn't played, because obviously if they've played B, they've played C, is B versus D. So here, in terms of complete all the list of matches, that is exactly what I have done. So let's have a look at example 2. So example 2 says the cards L, M, P are placed next to each other, and the question A is asking us to list all the possible orders of the letters, and the first one has been done for us. So for this, what we need to do is just write down the different orders. So here I'm going to start with L being first. So here I can have M and then P, M. So that's all the options I could have with L being drawn first. So now what I'm going to do is I'm going to change it so M is drawn first. So then I could either have L next followed by P, or I could have P followed by L. And then obviously that's M. And that's all the combinations of where M is being drawn first. So the next then I move on to is P. Let's say P is drawn first. So again I could have P and then L and then M and then M, L. And that should cover all the possible options that I could have in terms of those selections. Then moving on to B, it says the 3 cards are placed next to each other at random. What is the probability that L is the middle answer? Now for this, in terms of this, so here I've got a total of 6 combinations. There's 6 combos in total. So this is going to be over 6. Now how many of these 6 has got L as the middle card? Well, that's going to be 2. So then the final answer is going to be 1/3. Now moving on to question 3, it says that a lunchbox contains 1 sandwich and 1 drink from this list. And the question A is asking us to list all the possible combinations that we could have. Now obviously we're supposed to write it in this list, but again there's no harm as long as I've got some system to it, then that's absolutely fine. So what we've got is going to start with cheese first, and I've started with blackcurrant. So then I can have cheese and lemonade, cheese and water. So that's all the options of picking cheese. Then if I then start on to ham, so again with ham I could have ham and blackcurrant, ham and lemonade, and ham and water. And then for my third option I've got prawn, so I could have prawn and blackcurrant, prawn and lemonade, and prawn and water. So all in all there are 9 combinations. And either writing your list in a table like I've done here, I know they start off by writing it in a list, but again you can just either copy the list down or just do what I've done there. Now for B it says 1 combination is chosen at random. What is the probability that it is ham and water? Now here, how many ham and waters have I got? Well, I've got 1. So the answer then is going to be 1 out of 9 because there are 9 total combinations. So let's have a look at our 4th example. So let me just make sure, yeah, 4th example. So it says the diagram shows a door lock. We've got 1 and 2 and then A, B, C, D. The code is a number followed by a letter. Steve enters a code at random. Work out the probability that they have entered the correct code. So for this what I need to do is list the options, or list all combos. And how do I do that? Well, I've got 1 and A, 1 and B, 2 and then C. Let's just go back. 1 and then C, and then 1 and D. And then I've got 2A, 2B, 2C, 2D. And so there's 8 combinations in total, so 8 combinations. So what's the probability that Steve's going to get it right? Well, it's going to be 1 out of 8. Now it's really important that you do show the fact that you're listing all combinations. So I would say you get 1 mark for listing, 1 mark for knowing that there's 8, and then 1 mark for your final fraction. Moving on to question 5, it says again very similar to the door lock. This time we've got a few more options. So it says the diagram shows a door lock, and it says that the code is a number, a letter, and then another number is entered by pressing a button from each row in turn. So top row, middle row, bottom row. Sarah knows that the code begins with 1, so she presses 1 first, and then she at random goes for the other options. So for this, all I then need to do is go for that list. So I know 1 is a given, so I can kind of ignore that. So the only combinations I'm then looking for are the second row and the third row. So here I could have A3, A4, then I could have B3, B4, and then C3, C4. So from this, then the question is asking, work out the probability that she gets the right code. Well, there's only 6 possible options or combinations, so the answer then is going to be 1 over 6. Then looking at example 6, it says that a 10p coin and a 2p coin are tossed. List all the possible outcomes. Use H for heads and 6 for tails. So again, if I just look at the 10p, and then I've got 20p. So again, keeping the 10p as a head, well on the 20p I can either get a head or I can get a tail. And then if I get a tail on the 10p, I can either get a head on the tail on the 20p or a tail on the 20p. And there are my 4 options. So what I need to do then here is just write HH, HT, TH, and TT for the 2 marks. Now looking at question 7, it says that in a college canteen, students can choose either a starter and a main, or a main and a pudding. One combination is soup and curry. How many different combinations are there? Now there is actually a mathematical calculation to do this, but as we're talking about lists and options, then what we're going to do is do just that. So in terms of the starter and main course, then the options are either S, C, S, B, or S and P. So that's when you just go for this first option. Now if I then went for main course and pudding, then my options are either going to be C and J, C and F, and then B and J, B, F, and then finally P and J and P and F. So looking at how many different combinations there are, well I've got 3 combinations for the first option, and I've got 6 combinations for option 2. So then 3 plus 6 equals 9 different combinations. Then moving on to question B, it says all the combinations are equally popular. A student is chosen at random. What's the probability that he has jelly? So what I'm looking for is which of these 9 combinations combined has jelly. So I've got 1 there, 1 there, and 1 there. Then the answer then is going to be 3, and because it's asking for probability, it's going to be 3 out of 9, which can be simplified as a third. Now with it only being 1 mark, if you wrote 3 over 9 you should get the mark, but again with fractions you should always try and simplify where possible. Now for the final part of this particular example, it says that the canteen serves 270 students on Monday. How many jellies would they expect to serve? Well for this, the answer is going to be looking at relative frequency, so it's the number of students, which is 270, multiplied by the probability of them having jelly, which is a third. So then all I then need to do is do 270 times a third, or divided by 3, whichever floats your boat, and you should have an answer of 90. Moving on to question 8, it says that there are 3 types of Easter eggs, so you can get milk, dark or white chocolate, and eggs comes in 3 different sizes, small, large or king size. List all the possible options that we could have. So again, I'm going to set up my table, so I could have milk, chocolate, in which I could have small, large and king. So again, M, M. Another option then is dark chocolate. So with dark, I could have small, large, and king. So D, D. And then with the third option of white chocolate, again, I could have small, large, and king size, giving me a total of 9 combinations. So all I need to do is just copy that into the list. So I've got M, oh, let's just make sure it's on the line. Here I've got MS, ML, MK, and then DS, DL, DK, and then WS, WL, WK. All the 3 marks. Now, if you could go straight into the list, then that's absolutely fine, but I always tend to find working in a table tends to work easy for me. Next question then says a box contains equal number of each egg. 1 egg is chosen at random. What is the probability that you go for a small chocolate egg, small milk chocolate egg is chosen? Well, how many MS's are there? Well, there's 1, so it's going to be 1 out of 9 because there's 9 different combinations.